Visual tool control provides you with the ability to quickly audit your tools, to ensure that all tools are present, and more importantly, identify which tools still need to be returned. The idea of a place for every tool and every tool in its place. Not only does this save time, but it also ensures your investment will be protected for years to come. Today I'm going to walk you through the process of setting up your toolbox using Fusion 360, some foam, and a CNC router. The process isn't difficult, but it can be time-consuming, so get ready. The process starts by taking a high-resolution photograph of the part, but we want it to be a silhouette. To capture the silhouette of the tool, I created a giant shadow box. Basically, I have an LED light at the bottom and a piece of plexiglass, and the light shines up and creates a contrasted image of the tool. I can then photograph it with the camera with the white balance adjusted. Turns out pretty good. I then pulled the image into the computer, and using the image software adjusted the contrast and the white balance and all the other controls until I had an image that was very contrasted. You want it to be sharp so that when you auto trace it, you will get as much detail as you can with as minimal distortion as possible. I then uploaded the file to Convertio, which is an online file conversion program, and converted it to a scalable vector graphic ready to be imported into Fusion 360. Like most Fusion 360 drawings, you're going to start out with a sketch, and you're going to import the scalable vector graphic to that sketch, and then draw a line across that part and get a length or a measurement that you can use to scale it. The part measures 10.5 inches in real life, so it measured quite a bit longer. So we're going to scale this down. So we're going to take 10.5, divide it by 15, and that gives us a factor of 0.7. Now re-import your scalable vector graphic, and this time scale the model by your factor value 0.7 or 70%. This will give you a one-to-one real-world model. Take a few minutes to clean up your sketch. You're going to see some artifacts from the photograph. Just clean that up, make it look good. Once you have the sketch cleaned up, you're ready to extrude it to whatever the desired depth is. In the case of this hammer, I find that about a 1/2 inch is adequate. It still allows you to grab the hammer, but also doesn't take up too much space in the toolbox. So we're going to go with a 1/2 inch. Some tools, like the digital calipers, will require finger holes to access the tool in the foam. And so add those to the sketch and extrude them, and that'll give you, or the operator, a place to grip them and pull them out easily. Once you've created solid models with all the appropriate cutouts and modifications that are required, you can arrange them in whatever order you want that fits within your toolbox geometry. Here you can see I've got my top drawer laid out, and I'm simply using the combine tool to cut out the negative space from the foam. And I find this to be much more efficient than trying to maintain 2D sketches with various depths. Also, when I get new toolboxes or additional toolboxes, I can recycle those tools, make new foam. It's very easy. The cutter is made by ONSRUD. It's a 1/4 inch carbide 2-flute upcut designed specifically for cutting foam. You can plunge directly in, go about as fast as you want, and it leaves a good finish. Been very happy with it. So the cutter we're using is made specifically for foam, but one of the things that we encountered early on was that occasionally that foam would want to wrap around the part, especially if it was long. And so the first thing we do is we go through and we cut up all of the longer areas just using a slot. And then we come back and we profile all of the cutouts. And following the profile, we do a parallel finishing. And I found that doing the parallel finishing at a 45 degree tended to give me a little bit better finish, and it also discharged the segments a little bit better. And that's likely due to the shape of the parts I'm doing. But I also found that if I could go both ways, both climb and conventional, it would increase my speed overall, and this allowed me to get more work done per day. I ordered the custom foam blanks from Foam Fit Tools. This is the second time we've used them, been very happy with the quality. Here I am at the multicam router, and I'm cutting out the top drawer, and the fixture is pretty straightforward, just using some scrap plywood around the perimeter to keep it from having the potential to shift, and then also using the vacuum table to suck it down. And this has worked out phenomenally well. The dust collector is absolutely critical for your success. Otherwise, you end up with the little bits of foam wrapping around the cutter. And when that happens, what it does is it kind of burnishes or gets an area hot and melts the foam. And it just doesn't look very good. So this was some of the first footage that I shot using the time-lapse function, and as a result, no sound, but the video looks really good. Then went into the shop and began to load out the toolboxes. These are new toolboxes to us this year, and so these are all new tools, and so it's pretty important for us to take care of them and get them put away. And so it's kind of fun to open those Starrett boxes and slide all those nice tools into their resting place. We try to keep the toolboxes loaded with what an apprentice might need for their first year or two when they start. And of course, you'll build your number of tools over time, but this is the basics. After the first drawers were done, it was on to the second and third drawer, and went pretty quick. The router's working very well. The new pinion shaft that we put on last week eliminated our backlash issue. We put several hours on it and pretty happy with it.